So we'll come to now software, and here we can see that what are the results given by the software, right? So to start the software, we are using start and go for mechanical APDL 16.2, right? After opening, you will see this screen, right? So go for file, clear, start now, and click do not read. Then click on OK, right? Click yes, right? Now we have to do analysis. For that we have to go for a preference, right? So set preference, set a structural, and click on OK, right? Then go in a preprocessor, that is a first element. We are going to select a element type. In this element type, go to add. In this, click on add and select a beam element, and the beam element is having type 3 node 189 element, right? So this is basically 1D element, right? So click on apply. So you can see type 1 beam is added to the project. Now click on close and go for a material properties, right? In material properties, select material models, select structural, go for linear, elastic, isotropic, and in this click elasticity put elasticity of material as a 2.1 into e raised to 5 and Poisson's ratio as a 0.3. Then click on OK. Now material properties are set. Close this window, then go in section. In section, click on a beam, right? We have selected beam element, so click on a beam and select a cross section, right? So for selecting cross section, go on a common sections, right? Here you can see in subtypes there are different type of sections available, right? But we have taken rectangular section, so click on rectangular and put width and breadth, that is 100 by 100. Click on OK. Now cross section of a beam is set. Now go in modeling and create a line, right? So to create a line we need a key points, right? So first select key points, and to create a key points select in active CS. Here you can put first key point, and the coordinates of this key point is 0 0 0. Click on apply. Then enter second key points, and its dimension is 500 mm in x, is y, in y 0, in z 0, right? Click on apply and click on cancel. Now you can see there are two key points, right? So now we can draw a line between these key points, right? So close this, go on click on lines and select a line, right? In line you can select a straight line, and you can select first key point and second key point, right? Now one line is defined, right? But to solve FEA problem we have to divide this line into number of nodes and elements, right? For that we have to move to meshing, right? So we'll go for meshing. Then in this, click on mesh and click on lines, right? So select a line, and you can see here there are 10 elements: 1 2 3 4 5 6 7 8 9 10, right? So there are basically 10 elements and 11 nodes. Click on OK. Now line is meshed in elements and nodes, right? Next stage is applying load, right? So we are going to apply boundary condition. To apply boundary condition, go on define loads, select apply, click on structural, click on displacement, and click on nodes, right? So here one end is fixed and on other end there is a force, right? So we are fixing first node, so select first node and click on apply. Now we have to restrict this node to all degree of freedom, right? Means this node should not move in x y z or along x, along y, along z, right? So displacement of this point will also be 0. Click on apply. Now you can see there is a fixed support in x and y direction, right? So click on apply, and next boundary condition is a force at the other end, right? So click on structural, force, and on nodes, right? So select end node and click apply, click OK, right? So force is in a downward direction and it is in a y axis, right? So click select here Fy, select apply as a constant and enter the value of force as a minus 100 kilonewton, right? Then click on apply. Now you can see there is a force in a downward direction is having 100 kilonewton unit. Now boundary condition is set. The line is divided into number of elements and nodes. Now we can solve this problem, right? So go in solution, go in solve and solve this current load steps. So click on load steps and click on OK. Now you can see the problem is solved. So I will close this window, close this window. Now second step is over, right? Solver has solved the problem. Next step is a general processor. In this we are going to see results, right? So in this, select plot result and go in a contour plot. Sorry, go in deformed shape. Click here deform plus undeform and click on apply, right? Now we can see the maximum deflection is at the other end where force is applied, right? So uh, the maximum deflection is at the end and it's having value 2.45 right?
Now let's see the comparison of result. That is deform shape we have obtained, that is 2.45 but as I have told in first video, that is the deformation, actually that is deflection of beam obtained is that is 2.38 and this deflection is 2.45 so it is quite nearer, means our results got validated with our hand calculations. Now we are going for elemental solution, that is elemental solution stress, one minus stress apply. Okay, so at this condition it is not going to show any stress, but when we are going for plot control, style, size and shape, and then we are showing display of elements, then it will show elemental stresses. Here the value of maximum stress is 300, which we have already obtained through our hand calculations, that is 300 MPa, and here it is showing 300, hence our stress is also got validated. And here 2.48 it is showing, so which is nearer to 2.38, so these two values are also getting validated. So this is the basic thing which we wanted to provide you at the start of the semester, because we need to study more and more complex geometries and how the solution is done by Ansys and how Ansys is working according to our hand calculation, that we have seen already. So we are going to see some next videos related to our practical. So thank you.